Perfect. Welcome to this new video. In the previous one, we have seen the classic process injection technique. In this one, we are seeing the classic shellcode execution. Okay. So in this case, instead of inject the malicious shellcode into a remote process, we are just executing it in our local process. Okay. Perfect. Perfect. Welcome to this new video. In the previous lesson, we have seen the classic process injection technique. Okay. In today's video, we are going to show the classic shellcode execution. Okay. So in the previous one, we were injecting our malicious shellcode into a remote process, and in this case, we are just executing the malicious shellcode inside our own process. Okay. Perfect. The description is very simple. Malicious code is executed into our local process and directly from memory, often bypassing this basic detection mechanism. Okay. The steps here for this technique are very simple. First of all, we need to define our shellcode, our malicious shellcode. Then we allocate memory space. Then we copy the shellcode inside this new memory space. After this, we make our memory executable, and then we create a thread to run the shellcode. Okay, so the create thread functions starts a new thread at the beginning of the shellcode buffer, at the beginning, of the new memory space with the shellcode copied inside it, and then when it's executed, the shellcode is automatically run. Okay, perfect. So let's try to see this code in action in the virtual machine. Perfect. So here we are in Visual Studio, and that's the code. Basically, here we have the shellcode. This is the shellcode that we've executed. In this case, it's just opening a Windows calculator application. Okay, and then we start with the main function. This main function is very simple. We start allocating a new memory buffer. We use the virtual alloc function. To this virtual alloc function, we set the payload length, the size of the shellcode. We set the memory commit and memory reserve flags, and finally a page read-write. Okay, permissions to read and write this new memory buffer. After this, we copy our payload to this new memory space created just here. So we move our shellcode with this payload size into the new memory buffer. Then we make the buffer executable. We use the virtual protect function that is used to change the memory permissions, the memory security, this value from here of an existing memory buffer, and we change from page read write to page execute read. If you want, you can set directly at the first time in the virtual alloc function, you can set directly the page execute read write. So for example, you can do page execute read write flag, and you don't need to perform this virtual protect function, but it's usually used because the antivirus usually flags as malicious this type of read write execute memory allocations. Okay, so in this case, we create the memory space with execute and read permissions, and then we just change these permissions to execute read after moving the payload, after copying the payload inside this memory space, because we don't need write anymore in this memory space. We just need to execute. So we pass to execute and read permissions, and then with the create thread function pointing to the memory buffer created here, we can just execute our calculator application. So if we run our code, the code is internally compiled, and here we have changed this, but it's not the correct one. This is the page read write and then the page execute read. The previous error was because we were trying to write this memory space where we just set execute and read, so we don't have permissions to write. So we just change this line of code, and if we re-execute the code, in this case modify it, and all works good, a calculator application will be automatically executed. Okay, perfect. So that's the classic shellcode execution technique. use it in Windows. Perfect. See you later.